Okay, so today we are going to be doing the second activity of the Code Conquest Seniors, and this is going to be all about variables and objects and how you create them, and we are going to end up making a little sketch where we have a bunch of bubbles that we can then hopefully pop, and it'll be really fun and exciting. So here I have our editor, and this is where we're going to be doing everything today. I kind of have stuff set up, and in the starter here, we're going to give a function for doing an animation for a popped bubble, just because with this one, it does involve radians as well as some other trig functions, and that would probably be scary to some kids. Let's be honest, I'm an adult and it's kind of scary to me. So we're going to make sure that we give them this function so that they don't have to make it themselves. But what we're going to be doing today is making some bubbles on our screen. So let's get started. So one of the first things that we want to go over is variables with the kids. They should be familiar with variables like X and Y now in their math courses, but they probably won't have seen it in a computer science context, because what they're used to is me just plugging in a single value. So I can see that, they'd be like, something like x equals 5, right? And they'd be used to the fact that now whenever x is referenced in the future, it's 5, right? What they probably don't understand is that then later on you could say like x equals 7, right? And that'll actually change the value of that variable. So they should be used to the idea of kind of symbols that you can use as placeholders, right? So like X and Y, but they're probably not used to the idea that you can change that in code. So that'd be a good thing to start with. Maybe go over that on the board, go over any questions about that, and get that nailed up. But we're going to now create some cool circles. So what I first want to do, right, is I'm just going to draw an ellipse on this, and we're going to put it in the center of my screen so that we get 200, 200, and let's make it 20 by 20. I'm going to do this. Hey, look at that. We can now see a cool little bubble is what it's going to be in the center of our screen, right? And they should have just done this in the preview activity, so they should get that pretty quickly. But what we want to do now is make it so that our bubble can move around the screen, right? And to do that, we're going to need variables. And so this is where we can start getting in on this. So in JavaScript, you use let to declare a variable, and they are dynamically typed, so you don't actually have to say what type of data it is, which is really helpful to the kids. That's one thing that they can struggle with, like what is the difference between a string and an integer and a float? In JavaScript, you don't have to deal with any of that. The program deals with that all for you, which is a bit of a blessing and a curse at times. So don't worry too much about that. Just basically say like this is a variable and just use it as a catch-all. I wouldn't even explain to them the differences between types of information right now. That can get really confusing fast. But so what we're going to do is we are going to redraw this ellipse with variables. So we're going to have an x, and we're going to make that 200. We're going to have a y, we're going to make that 200. Oops. The spaces don't actually matter, but I like having good spaces. And then we're going to be having a size, and let's make that 20, right? And in this, then we can replace this with x, with y, size, and with size. Okay, cool. So now we can see that we have an ellipse on the screen, right? And we changed around the variables, and now we're doing this, right? So now I can go and change where this ellipse is just by doing this. You can see I moved it off to the left, I can move it way out to the right, I can move it down a whole bunch. So I can now move it around our screen, right? I'm going to set it to 200, 200. And this is really cool because it's going to allow us to change things in the program. So in the previous example, we were just using setup to draw. And this is a good time to go over what the difference is between setup and draw. These are two functions that come with processing, and you'll be doing most of your coding inside one of these two functions, right? So the setup, it runs once at the very beginning of the program, and then the draw will run once every frame, which is about, I wanted to say it's about 30 times a second, but I realized, yeah, it should be capped at 30 by default, although you can go in and change that. For the kids, I probably wouldn't recommend changing it at all, just keep it at 30 FPS, and that'll be fine. And yeah, and another thing you might want to have to tell the kids about is something called scoping. This is a topic that gets complicated quickly, but it is important to understand, which is basically that variables only exist within the place that they are created, right? So with X, Y, and size here, right, they're at the global level. They're on the kind of the most outside level of my program, so they can be accessed anywhere, right? But if instead I put these, I'm just gonna quickly copy, and I'm gonna paste them inside of my setup, right? Now you can see that the program's getting mad at me because even though those variables still exist, they exist in a different place. Now they only exist within setup, within these two brackets, right? And so I can't access them inside of draw. And if you've ever done like coding before, you know this, but this is something that the kids probably don't and is worthwhile going over for sure. Okay, so now I have a circle on my screen, and I want to be able to make it move. So what I'm actually going to do is just kind of like make it jitter around randomly. So I'm going to say x equals x plus, and first let's before we make it do random, let's just say x plus 1, and let's see what happens. Right? And we see now that our we're moving over time. Our x value is changing over time. And if the kids want to see this, you can also use a print statement, and you can just say print x. Right? And we can see here, this is in our console, this is where the values of x are. And it went completely off of our screen. It's only 400 wide, so at this point my ball is floating somewhere there. But using the print statement is a good idea for the kids because they can actually see the variables as well as see moving, and that should help them understand like what is happening here, right? But I don't just want it to move off my screen. I actually want it to move around randomly. So I'm going to say x plus random, and I'm going to say negative, let's make it jitter a lot. Let's say negative 5 and 5, right? And what random does is it just picks a random float, so that's with decimal points, between these two numbers. And if you're more curious about how that works, there's the p5.js reference that you can go to. That's here. It does everything. You can search it and say if you're like, oh, I want something that's random. Oops. There we go. Random, random seed, random Gaussian. You can play around with those. Those are all really cool. Right. So now, we can see that it's moving randomly along the x-axis, and we're getting these really long float numbers now. If you want, you can type this to an int by saying int, and that'll make it, or even better, actually, you could say round. Actually, the kids will probably understand round better than int, because to say int, you'd have to explain what an integers in computers are, and they should know what an integer is. But it's probably easier just to say round, and that just rounds it to the nearest whole number, right? And we're going to be doing the same thing with y, so we can say y equals y plus random negative 5 and 5. And if you want, you can even just copy and paste the previous line and change the x's to y. I'd actually recommend that. Generally, the thing that'll slow you down the most in any of these activities is just how slow the kids are typing, like painfully slow. So yeah, copy whenever you can. Also realize that I'm taking forever with this video and I have a whole bunch more to do, so I'm going to speed things up a little bit. We're not going to go over that for right now. So I'm going to get rid of that print statement. And so now let's do it where we are trying to make a second ellipse, right? So if I wanted to make a second ball here, because what we're trying to get them is to understand what objects are, right? And how you can use different objects to have multiple things on the screen. So right now I just have an X and a Y and an ellipse, right? And if I wanted to make a second ball, right? If I just said like, oh, let's make a second one, let's draw another one and put it at like X, Y, size, and size, right? Now I have two balls that are in the exact same place, and that's not very good. So how can I fix that, right? Because I want two balls in different parts of the screen. And so to do that, right, I have to make like x2 equals maybe, let's say, like 300, and then like let y2 equal 300, right? And then for the second one, I'd have to say x2, y2, right? Oh, but then I also have to go and I have to copy in like this. I realized that I should probably do this before I draw the ellipse. Technically it doesn't matter, but it will delay it by 1 frame, and that can mess up some of your conditional logic later. So you should always be moving your coordinates before you draw the thing, if you can. Right? Okay, so now we have here we have x2, x2, y2, y2. Right? Okay, so now we have two moving around, but like that was kind of annoying to do, right? And this is going to make my code get really messy, really fast. And I'm going to have so many variables. Like what if I wanted to make like 10 of these? I would have to go and do this every single time. I'd have to rewrite all these things, and like nothing about this has really changed, right? Like so much of this code in the two places is similar to one another, and this is where we can really get them to understand like why we use objects, which is, okay, if you have two things which are the same, but you want them to like behave independently, you want them to be able to do different things, but they're still like just different versions of the same thing, this is when objects are really, really useful, right? So we're going to stop this, and now is when we can show them, okay, how can we actually make an object and why is it useful? Right, so then we'll go, and this has to be done, I think this has to be done at the global level in processing. And we can make a class, and we're going to call it class bubble. Right? So inside of these brackets is our class bubble. You don't have to do it with a capital letter, although capital letters are kind of the standard, so I would probably recommend sticking with that. Okay, so how do we actually go about creating this? One very important thing that we need is we have to say that there is a constructor. Okay, and this is a lowercase, so this is the thing that will actually create our object. This is the function that will get called when we actually do it. And this might also be a good time to go over like what a function is. They should have come across functions in math before, in math class, right? You know, like x equals like, you know, mx plus b. Like they might have come across like simple equations like that, and just really say like that's kind of what's happening here as well. So if I had like and you say it by saying function. Actually, maybe before I go and finish off this bubble, let's go through what a function is, right? So let's say I have a function that's like move, right? And I'm going to say, oh, it's going to take in an x value and a y value, right? And we're going to do the same thing that we did before, right? Where we take an x and y, we move it, and this is just like some action that's taking place, right? Is that we are going to be, oops, you basically, like, you take in the variables and they get replaced inside of here. They should be able to get this. When I was teaching the kids got this pretty quickly, so I wouldn't dwell on it. But it is something that's probably worth going over. So for now, we're just gonna get rid of it though, because we're going back to our constructor here. So this is a function that's making our object. It's what's actually going to run when we want to make a new object, right? When we're creating it for the first time. So in this is where we're also going to store all of our variables, right? So what did we want to be able to say for our ellipse, right? Is we wanted an x, a y, and a size, right? So we're going to put those as parameters into our constructor, right? So in this, we'll be able to tell each ball to have a different y, a different x, and a different size. And to do this, to actually set this to our object, we have to use the this syntax, this dot, right? So let's just type this here. Oops, I cannot spell. Okay, so now we have these three, right? And what this is doing is it's setting variables that are now stored within our object, right? They exist as part of our bubble now. And this will be more obvious once we actually make it and the kids can see what's happening, right? But basically, the most important thing to remember here that the kids might forget is the this dot. This dot is really important. It basically references the object that I am currently within. I'm in this object. And the dot syntax then is how you say, okay, I want the x value of this object, right? And if you want, you might even be able to like draw this out with like boxes on the board and fill in stuff like that way, and that might make a bit more sense if you have kids that are confused. That's kind of up to instructor discretion though. So let's go now and let's show how we would actually turn this code into an object, right? So instead of needing all three of these variables now, we actually just need one. So let's start with let bubble 1, right? And we won't assign it a value. We're actually going to assign it a value in the setup. We probably should have done that with these ones as well, and maybe with the kids you can get them to declare the name here, give it a value in setup, and then actually do things with it in draw, just so we keep with the same pattern. Because that's what we should be doing with objects. So in the global, if we want to access it globally, we will declare the variable name. That's basically telling the computer that we need to make a single object, right? And there's kind of 3 steps to creating an object. You create the variable name, and then you go and you assign that name a value. So I'm going to say bubble1 equals new bubble, right? And here is when I'm calling the constructor value, right? So here I give it an x, a y, and a size. So I want it to be the same as before. I would say new bubble with 200, 200, and 20, right? I'm actually going to get an error because these are no longer defined. So maybe let's just get rid of that. Yeah, let's just get rid of it. Okay. But size is not defined. Size is not going to be defined. So as we're in the process of making these unfortunately won't run, right? And we're still missing things though, because we haven't told the bubble what to do. We've created it, right? But our third step is going to be actually telling the bubble what it needs to do. And to tell the bubble what it needs to do, we're going to need functions within our bubble class. So let's make two of them. Let's make show and let's make move. Right? So inside of show, we're actually just going to be saying basically the same thing that we said outside, except instead of using x and y, we're using this x, this y, and this size. Right? So now what we can do is in our draw, we can say bubble one dot show. And hey, look, now we can see our bubble, right? And this allows us to save a lot of lines of code, right? Because even though for one single bubble, right, it was probably faster to do it with just like the, the X and the Y and stuff. But if we have like 10 or 20 or 1,000 or 1,000,000 bubbles, right, it's going to be way, way shorter just to be able to say things like this, right? And then what we did before, right, with my X and my Y, right, and I had that copied to my clipboard, so maybe before we delete it, make sure that the kids move it over so they don't have to rewrite it. Except then instead of saying X, right, I'm saying this dot X and this dot X and this dot Y and oops, this dot Y, right? And so in this,
oh, you're here.
Hello.
Like everything's so dark.
Cool. I don't have time to talk right now. I'm actually recording a video. So if you can just drop off your stuff if you need them. Okay. So we have our this dot Y and our this dot X, right? And so we have our move function here completed. And now we can do that inside of our draw as well. So we can say bubble one dot move. And now it's doing the exact same thing. Right? And the kids might be like, oh, well, that's cool, but like, how is this any better? And now we can show them what happens if we create another bubble, right? Because now it's even easier because we already have everything created. So let's say now we have bubble 2, right? And so we say bubble 2, so we follow our 3 steps of creating an object. So we create the variable name, and then we assign it a value. So we say bubble 2 equals new bubble 300, and let's maybe make this one smaller, this one, and 10, right? But nothing's there yet because we also need to tell our bubble what to do. So now we say bubble 2 dot show. There we go, it's showing, but it's not moving because we need to say bubble 2 dot move. Cool, and now we have 2 bubbles on our screen, and they're really awesome. And we can keep doing this with as many bubbles as we want. Like we can create a third one, and at this point, I'm just going to copy paste things. Create a third one, change it around, so maybe it starts at 100. Where did that go? Oh, that's because it doesn't exist yet, because I didn't do my third step. Right, and this becomes really easy to make new ones. Right, and at this point the kids will probably, I would just like let them go for a bit and let them create like, they'll probably want to create like 20 of them, like moving all over the screen randomly, and they'll love it. And that's when they start to see the value of having objects, because you can create the same objects again and again and again without having to type a whole bunch of new lines of code, right? And so this is where objects become really helpful, right? Is we can keep a whole bunch of variables in one place, and we can tell a whole bunch of actions to in one place, and it's kind of all encapsulated within a single spot. Okay, but there's not really any cool things happening here yet. So what we're going to do is we're going to start adding some interaction to this. So what the goal here is going to be is that we're going to be able to move the mouse over top of our bubble, and it's going to pop, and it's going to show a little popping animation instead of the circle. So to do this, we're going to need to introduce the kids how we kind of get interaction between things as well as like what booleans are, like what true and false values are, and how we can do some basic control flow in our program. So the first thing that I'm actually going to do, because I noticed that all of my bubbles have rudely left the screen, right, is that I'm going to actually say constrain. So constrain is something that it'll take a value and then two other values, and it'll basically just make sure that the variable stays between those two things. And this is important because it means that our bubbles will no longer be able to rudely just wander off our screen. Okay, so we have that. You may want to get constrain is not defined. Oh, that's because I can't type and I did it twice. Okay, constrain, there we go. So now our bubbles shouldn't being the keyword, shouldn't go off the screen, and they should all stay there, because if they do reach an edge, they won't be able to go past it, right? You can see this bubble on the bottom, it's kind of flirting with the edge there, but it's not actually going and running off the screen anymore. So that's cool. That was a little side note though, because let's get back on to what we want to do with our popping, right? And to do this, we're going to want to add another value to our object here, right? And what we're going to do is say this dot popped, right? And we're not actually going to start with it in our constructor as a parameter this time. We're just going to set it to false, because we want the bubbles to start not popped, and it's only when we put our mouse over top of them that is when we're actually going to go and pop them, right? And because this is going to be a new behavior, we should write it in a new function. So we're going to say pop, right? Oh, actually no, I can't say that. I'm going to say pop bubble. So the reason that I'm naming it this is that you can't name it pop because that is something that already exists in processing, and labeling it popped technically I think would work, but would probably get confusing, so we're just going to call it pop bubble. And in this is when we're going to get some interaction with the mouse, as well as some conditionals. So this is where we can go over if statements. I would go over some like if statements on the board. You can even do like some if-then statements with kids, and like play a game that's basically like Simon Says, where you're like, if, you know, like I put my hand in the air, you should all like stand up or something, and kind of get the idea in their heads that they can, you can respond to certain things in different ways, like depending on conditions that you're given, right? So in this, we're actually going to say if distance between this dot x and this dot y, and mouse x and mouse y. So just this dist here, it just calculates the distance between 2 points, and we're going to say if this distance is less than or equal to this dot size, right, then we should set popped to true, right? So we'll say this dot popped equals true, right? And nothing's happening yet because we haven't called this, and we haven't done anything. So we can see to show the kids at this point is you can just say print this dot popped, right? And then in each of our bubbles here, though, I'm going to say bubble, bubble 1 dot pop bubble. Right. We're going to copy that line, right? And we're going to do it with number 2. Oops, that's number 3. Number 2 and number 3. Right. And now, right, if we go over top of them, right, we should see that it prints out just the value of it. But basically, we can see that it is working. When we mouse over one of them, we start getting this true printed out. And now our bubble is popped. Right? So that's just kind of so that you can actually see what's happening, but we can just get rid of that line for now. Because now what we need to do is go over some slightly more control flow in our show function, right? Because when it gets popped, we want to show popped. And I made this popped bubble function down here, right? So what we're going to do is in our show, we're going to say if this dot popped, right? Then we don't actually want to show the ellipse. We want to show popped bubble, right? And we're going to say this dot x, this dot y, this dot size, right? And T is going to be for transparency. You don't actually have to. So you will have to specify T, otherwise it'll break. So we're going to have to say this dot x, this dot y, this dot size, and for transparency, right now, just say 255. Okay. Oops. And what this will do is this will make it full transparency. Yay! And we can see what's happening here. That's kind of fun. So we kind of get this popping effect on our bubbles, right? Which is very interesting. But right now we're still drawing the circle, right? So what we want to say is we only want to draw the circle if it hasn't been popped, right? So this is our other case. So we can just use else in order to do this. Right? Down. And as you can see, I'm auto formatting things as I'm going with the indentation. You can hit tab and shift at the same time to auto format things. Unfortunately, it also throws your screen like up to the top, but it will auto indent things. So that's a really useful shortcut. Pop and pop, right? So you can see that the bubble, what it's also doing though is it's also turning things white. So we should all, before our ellipse, we should say stroke of 0. Uh-oh, what did I do? Stroke. Oh, I just can't spell. Cool. Stroke of 0. Pop, pop, pop. There we go. Look at that. That's so cool. Pop, pop, pop. Let's just keep stroke right down here, everyone. I'll change the stuff I'm changing right now. You don't have to worry about. It's just so that we can make it easier. Okay, yeah, let's make it black instead of white. That's a little better. Okay, so I'll make sure that that's in the starter. Cool, so now we have them going on and they're popped, right? But we also probably don't want them to keep moving after they've popped, right? If they're popped, they kind of don't exist anymore, right? So we want to say that same thing in the move, right? So we just basically say if, and in this one, we're going to say if not popped, right? Because we only want them to move if they are popped, right? So in this one, we're going to say only if they are not popped should we move them around. Okay, there we go. And we just did that by adding in an exclamation mark before, right? So you have whatever the variable is, and if you add the exclamation mark before, that's how you say not in Java. Cool. So now we have 3 bubbles floating around our screen that when we mouse over them, they pop. And that's kind of fun. But we want to do one final thing here. And that is going to go through and we're going to add in a transparency value, because what we want to happen is that when our bubbles pop, we want to stay them and pop forever. We kind of want them to pop and look like they disappear. So we need to do one more thing here. We're going to say this dot actually, we're probably just going to say this dot t because transparency is a long word and the kids suck at typing. So we're going to say this dot t, and it's going to equal 255. So at the beginning, right, it's just going to equal 255. because we want them to be seen. But then as the bubble is popped, right, we want to decrease that transparency, right? So inside then of if this dot popped, instead of 255, we're going to say this dot t, right? And then we're going to say this dot t minus equals 5. And what I did here is I just did now you might want to do it earlier, you can do it down here as well, but this is a shorthand way of saying basically, like what I just wrote here is the exact same thing as saying this dot t equals this dot t minus 5, right? So it's just a shorthand way, so you don't have to retype out this dot t. You can just say this dot t minus equals 5. Subtract 5 from whatever is over here and set that variable to it. Okay, so now let's try this. Pop. Cool, and now I see when I pop each of my bubbles, they disappear, right? And that is really, really fun. And you can get the kids, I would encourage them just like at this point make more bubbles that they can go and they can try like to pop them on. You can like make them small and fast too, so they're like legitimately hard to pop. So what you can do then is if you want to make them harder to pop, you can change this 5. You might want to set like another variable like this dot speed, right? And you can set it, maybe let's make it 10, right? And then here, instead of saying 5, you can say minus this dot speed, and oops, this dot. Right, so now they're moving really fast along the x-axis. You can do that for the y-axis as well, and if you want, you can then also add it into the parameter series. You could say speed, and then this would be like speed, right? And you'd have to go and, yeah, because none of them exist, because you'd have to go and change that up here. So maybe I make one of them really slow, but another like ridiculously fast, right? And the kids can just kind of have fun with that. I think like probably less than 5 is a good value, because you can see if it gets like to this 20, like that's ridiculous. But it's kind of fun. And we can say this dot speed and this dot speed again down here. Cool. Yeah, now they're just moving all over the place. Right? And trying to mouse over this guy is going to be hard to do, especially if it gets small. So those are fun things that kids can do. And then one final thing that you can do is you can add in color if you want. Color is really cool. So what you can do is use the fill to change the color of the inside of a shape. So this is what they were used to yesterday, right? Is you can go over and have that RGB value, or not yesterday, what they were doing earlier in the day. You can go and have that red, green, blue value. And this is really cool because you can start adding in color. For now, in this one, I'm just going to show, because the video is already long here, so I'm just going to show all like the same color. Like if I wanted to make them all red, let's say, what I can do is I can go and Google a color picker, right? And oh, sure, that's right. And what I can actually do is copy in this hashtag number. Instead of having an RGB value, this is a hex value that translates to this exact same thing. And I'm not going to go into the details of that, right? I don't think that it wants. Oh, 1 second, let's look this up in the reference. You should be able to add in a HSB. No, that's not. Oh, that's it. Okay. So if you do it with the hex value like this, you just need quotations around it, right? Ta-da! Look, suddenly everything is a different color. And if you want, you can then once again like add that into here. You'd say this dot color, right? equals color, right, and add that here, color, right, and then in your fill, right, you wouldn't say this anymore, you'd say this color. Right, and then once you're creating the objects, you have to go through and add a color to each one. There we go. Oh, we're missing a bracket. We're missing a lot of things. What's going on here? Oh, too many brackets. There we go. And you can change each one of those. Like if you want one to be green, you can copy in the green. Right. So let's make this one green. Yeah, now we have a green one. So the kids can have like lots of fun with that. You can change the background, so it's the same thing, right? You can do colors on the background, and they can have lots of fun with that. So I would just let the kids like play around with this, make stuff move in different patterns. Instead of using ellipse, maybe they want to play around with different shapes and do like a rectangle. Whoops. Oh, yeah, so rect, you need two of these. So now I can have rectangles going. I know, the kids can have fun. They can look through the reference and fiddle with different stuff. I'd probably recommend that they use either an ellipse or a rectangle. Those are kind of the easiest two to work with. Triangles get quite a bit harder. Because you can go look at that. I'm not going to spend time on this video. Yeah, but there's still lots of fun things that you can do with that, and I think that it'll be a cool activity that teaches them a lot of things which are going to be useful and fun to play with. So yeah, thanks for listening, and I hope that this made sense and that we all learned something. Cool.